going to talk on history of Islamic science and alternative narrative. Professor Saliba.
Thank you very much. You can hear me in the back? Thank you. What I intend to do today is try to make the case as to why we should not study the history of science, of Islamic science, the way it has been studied for the last 200 years. Two, why we should make use of the new findings over the last 40 years or so to rethink the method by which we study the history of science. In other words, we should study it back from the foundations of the texts themselves with what they tell us. And hence, I will be very, very brief because I think I have 40 minutes and I hope the chairman will remind me when I have 5 more minutes so that I can go on with this. So the first slide, I hope it works from here. I would like to give you just a very brief, quick survey of what is called the traditional story that I will refute. I promise you, I will refute every angle of it, but I will tell you why I need to refute it. We are told that there was this fantastic Greek scientific miracle that somehow came into being, and we don't know how, but it proved itself to be the mother of all foundational science, to which modern science still owes its growth and so on. Then we are told that this Greek miracle was translated into Arabic for the preservation reasons that Professor Gulshani saved me the time, because he quoted all those people who told you that Islamic science was only an intermediary because it was saving that Greek legacy. So we will come back, but obviously it is quoted all over the place and we all know it. Then we are told that there came the story of Imam Ghazali, that he was anti-rational, he warned everybody, he killed all the sciences, and from there on irrationality reigned, and from there on you couldn't possibly have any more science in Islamic civilization. I hope I will also cast tremendous amount of doubt on this particular statement, because I will focus on the scientists that came right after Imam Ghazali and well into the 16th century and show you exactly what they have done from the sources themselves, so that if we blame him for the right reasons. And I hope that we don't blame him for killing the science. I don't think he did it. Then there is also another story that the Arabic and the Islamic science reached Europe somewhere between the 10th and the 13th century. Europe took them up, they thanked them, and then from there on they developed their own sciences, and from there developed the Renaissance and all that, and left the Islamic world to slumber and go back to the declination that it is now. That I think is repeated all over, and we are told that the European Renaissance itself was indeed a recapture of Greco-Latin antiquity. It was not a recapture of anything else, and I will cast doubt on this story as well. Now, I want to show you that this kind of history has problems. Not because I don't like it, not because people say these things. It has problems in explaining the facts. In the facts here, I mean the sources that we have. The first problem that comes with it is in the beginning story. It tells us that the beginning story is that science arose, and when it was translated from the Greek material, and here I'm speaking particularly of the so-called foreign sciences in Islamic civilization. It does not also explain the end, because it tells us that the sciences were killed with the Ghazali attack and so on. So I will explore both of those in the beginning. And the additional story is that we are told that the Greek sciences came into Islam just at the Abbasid time. I don't know why the choice of the Abbasids, but I will show you that this particular choice is very poor. The reason for it is that with the earliest Abbasid sources that we know that the city of Baghdad itself was founded by Khalifa al-Mansur, and in its foundation in the year 762, that's as early Abbasid as you can get, within 5-6 years of their establishment, there we have in the sources that al-Mansur called the astrologer by Ibrahim al-Fazari, an astrologer by the name of Nawbakh, an astrologer by the name of Masha'Allah, and asked them to cast the horoscope for the city of Baghdad. Does any of you know how to cast a horoscope? If you don't know, let me tell you, it involves a lot of computations, a lot of observational astronomy, it involves a lot of precise mathematics, and it involves knowing where the planets are at a specific moment. This is not a joke. So I asked, if the translations of the Greek sciences happened and came during the Abbasid time, Mansur was not participating in this activity, nor were these astrologers. Where did he get them from? Who taught them how to cast a horoscope? Who taught them how to observe the positions of the planets at that moment to cast a horoscope? So I need questions of this nature. Otherwise, I can't accept the story as it is. I think I should have given you the English translation of the horoscope just for those who can't read Arabic. The second evidence that I have, and that's a very problematic evidence. I look at the earliest translations of the Greek text, and the translation I'm looking at here, I think this is a pointer. Oh, this is very good. Thank you, Charles. This little thing here has everything. It has a pointer as well. The earliest translation text is by Al-Hajjaj ibn Matar of the most difficult Greek astronomical text called the Almagest of Ptolemy. This translation was finished in the year 829, and barely the Abbasid period had not even rolled into 100 years yet. Already we find in the Greek text, and here I give you the Greek text, and the Greek text asks us that we divide this number by this number, and the Greek tells us, and here is the Greek text by the way, tells us that the result will be 29 days, 31 over 60, 50 over 60 squared using the sexagesimal system. If you indeed divide this number by this number, you get this answer and not this answer. So what Al-Hajjaj was doing, he indeed quotes in the Arabic text, by the way, he quotes the correct number. So he was correcting the Greek before he was translating it. I ask you, who taught Al-Hajjaj ibn Yusuf not only Greek, but here he has to understand the mathematics that is built within the Almagest to be able to critique it and to correct it, and this is exactly, by the way, the same number that gets quoted later on by Copernicus as the correct number of this division. So this intricacy, it is at this level of knowledge. This does not come when people are learning how to translate for the first time. So please worry about the story that told us that Arabic science, Islamic science started with the rise of the translations from Greek. Then, of course, comes the famous work of Khwarizmi that Professor Golshani had just referred to. The importance of Khwarizmi is not that he established a new book that he calls Kitab al-Jabr wal-Muqabala. Oops. Oh, we can go back, thank God. That he calls Kitab al-Jabr wal-Muqabala, as you see here. It is also that he had to coin a new word. There is no word algebra in Greek. Why does he have to coin the new word? Because the concept, the conceptual scheme of how the system works, on how the discipline works, what are the presuppositions of that discipline, did not exist in the Greek tradition as discipline. Of course, the Greeks solved algebraic problems. Even the Babylonians solved algebraic problems. But nobody thought of asking the question, what is it that we do when we do algebra that is different from what we do arithmetic? So it was Khwarizmi who invented the whole concept of the discipline, and from there on he gave us the theoretical exposition of it, the applications and so on. So the question is here again, this is at the very early time. Khwarizmi is working at the time just before or during Ma'mun and after al-Ma'mun, and it is in this time that somebody is beginning to say, let me step back and take stock of what we are doing and creating a new discipline. Usually this doesn't happen when you are translating or when you are learning how to translate during the Abbasid time. Then of course there was this famous introduction of the so-called Arabic numerals. Now Arabic numerals did not exist in Greek. They existed in Sanskrit, and we all know, by the way, Europe calls them Arabic numerals, but we who live in the Arab world and who have contacts with that, we know a little bit better where they come from. We call them Indian numerals, al-Hisab al-Hindi, which is correct as we are doing. But more important than this is that the Indian numerals were taken in. Again, Khwarizmi writes al-Hindi, which is correct as we are doing. But more important than this is that the Indian numerals were taken in. Again, Khwarizmi writes a book on the Indian numerals. So they were taken in very, very early in the Abbasid time, but very soon a new concept is added to them. The concept of the decimal point. In other words, the idea of the decimal fraction appears for the first time in a manuscript that we have it by Euclides from the year 952 in Damascus, and you see even the sign for the decimal point, as you see, is blown up here in both of those places. So in other words, there is a modification of the system, there is an improvement on the system, and without the decimal point it would be useless. In other words, you try to find a modern physicist who goes to the physics lab and tries to solve problems of 2.75 multiplied by 4.3, and without having the advantage of playing around with decimal point. So you will see the whole invention and the whole traditions of Khwarizmi left becomes part and parcel of what we call science up till this very day. Who taught Khwarizmi to do that? Ask this question. Who taught him? How did he come about to know about this material? So if we really were to think that it was all done in Abbasid time. Moreover, his contemporary, a man by the name of Habash al-Hasib, who is very poorly credited, by the way, nobody even pays attention to the poor man, although he was one of the most ingenious astronomers who worked in that period. He was trying to answer a serious religious question, by the way, is how to pray if you are in a city C and you have to face the city of Mecca to pray 5 times a day. The Qibla determination involves the solution of this trigonometric problem, which you find it right in here, by the way, with the arc cotangents, the sine, cosine, all of this. We only have the sine function from the Greek, from the Indian tradition, and the cosine. But the sine law, the cosine law, the rest of these developments, they don't exist neither in Greek nor in Sanskrit. Who taught Habash al-Hasib how to do this early mathematics? Who, in essence, creating what we call nowadays modern trigonometry. This is exactly what Habash al-Hasib was doing at that time. Then we have the observational astronomy. When we teach every single student nowadays in elementary science classes that the reason we have the change of seasons from summer to fall to winter and all of that is because the Earth axis is slanted by 23 degrees and a half. This slant of 23 degrees and a half, ladies and gentlemen, is neither the Greek value, which is 23, 51 and 20, so it's about half a degree too much, or the Sanskrit value, which is 24, which is a full half a degree too much. Or you might say Saliba is fussing over half a degree and all of that. No, I'm not fussing over half a degree. Small numbers, when they are plugged into what is the traditional astronomical number, meaning when you multiply them by 10 to the power, a higher power, they become huge mistakes. I'll give you an example. I will accept from you half a penny, but allow me to have 10 to the 10 of that, I will become richer than Bill Gates. So small figures, when you multiply them, they begin to be big mistakes. But the big question here is that why did they have to make the fresh observations and determine this new value? And as soon as they determined the new value, they began to find out that it was the observational strategy of the Greek tradition that committed the mistake. That it was not a slip of pen or a slip of tongue, that there was a fundamentally basic problem in the observational strategy that Ptolemy had committed, and now these astronomers, most of them, by the way, are working within, again, at the time of Khwarizmi, of Habash al-Hasib, between the year 830 AD to about 850 AD, and they said, when Ptolemy makes observations of the position of the sun at the end of the seasons, either at the vernal equinoxes or at the solstice, at this time, the observation, they said, it is very difficult to determine when is the shadow crossing from one day to the next. Hence, his mistake in strategy of observing should be corrected by making the observations in the middle of the season where a slight variation will be easily detected. When they did that, they immediately found the better answer. The better answer is the 23 degrees and a half. So you see, it is not also a beginner's luck. It is someone who is strategizing, who is thinking how we should observe, and how do we get the better results, and what does precision mean in the terms of observation. So in the beginning, I want to repeat those questions I asked you. Who taught the astrologers how to cast the horoscope of Baghdad? Who taught Hajjaj not only how to correct the text, but also how to create new technical terms? And some of us who have been involved over the last 30, 40 years or so in trying to create and help the Arab League organization that has set up an office in Morocco, I think, especially called Maktab al-Ta'rif, literally to Arabize technical terms, and they worked for 50 years and produced almost next to nothing about it. How did the poor Hajjaj, in the year 829, produce a complete text with full Arabic technical terminology, and we don't know who taught him. And also, as I said earlier, we don't know who taught him the complicated mathematics so that he could correct the text as he was translating it. How could modern science, as I said, develop without the Indian numerals? And how did, again, who taught Khwarizmi to create a discipline that we said algebra? And here again, the term ilm al-hay'a that Professor Golshani also referred to also does not have a Greek equivalent. There is no Greek term for hay'a. So they had to also create, and that is in the 9th century, ilm al-hay'a was created specifically against the Greek tradition to set up a new conceptual scheme of how astronomy ought to work. And hence, the minute an astronomer, or a scientist for that matter, feels the need to create a new concept, then you are actually producing science. Otherwise, you are just mimicking and playing with everybody else. Finally, who taught Habash to create the new terminology? And I think, as I said, the last part is who taught the astronomers of Al-Ma'mun to carry precise observations, as we have seen. Now, something must have happened, therefore, before the Abbasid times. Isn't that logical to say that all those people did all of those results just as soon as the Abbasids came to power, as if science was dripping from their clothes? That doesn't work that way. Something must have happened, and here I invite, in the first 2 chapters of my last book that I called Islamic Science and the Making of the European Renaissance, I invited people to look at the Arabic sources. The Fahrist of Al-Nadim, which has been so poorly studied, horribly disregarded, and now I understand it is even being printed nowadays all over the Arab world, and you can buy it for the equivalent of $2 and nobody reads it, because they think it's only a catalogue of books. Ibn Nadim was probably the first historian of culture that we ever produced in that civilization, and he was the one who told us. When the Arabic translations from Greek, from Sanskrit came, all of that, at the very end he said, this was not the first translations to happen. The first translation says happened during the time of Abdul Malik ibn Marwan, during the translation period of the so-called Ta'rib al-Diwan. Now everybody misunderstands the word Diwan, because like all children of a language, we only catch the last phase of the language, and we think Diwan is only the place where the king receives his guests and he says goodbye to them, or he sits and arranges all of these things. In the traditional sources, Diwan was Diwanu Wujuh al-Amwal. And we are told that by people like Jahshiyari of Tarikh al-Wuzara, people like also Ibn Qutayba. Those are the Diwans that they were worried about. And in fact, when we are told about how the Diwans were translated, the first question was, how do you do these mathematical fractions with it? So Wujuh al-Amwal was part of the construction of that Diwan, and immediately as soon as you have to worry about the mathematics, the computation of fractions, of course you have to worry about surveying, because when people die, they leave a legacy, and usually they don't leave land in perfect geometric forms. So all legacies we know have to be reassessed and resurveyed. All of this is part of the Diwan work. So there must have started right after, when Abdul Malik started the revolution of Arabizing the Diwan, there must have been also the elementary sciences that came in. It is these elementary translations that created the technical vocabulary, that created the arithmetics, that created the disciplines that we later on find in the Abbasids. So when the Abbasids come, they just reap the fruits of what the Umayyads were doing. The poor Umayyads were out of the picture because they ended up with a caliph that we call Marwan al-Himar, if you remember. In other words, it was the decline of the Umayyad dynasty. And this is what puts things back into focus, so that we should not think that people, just because they are Abbasids, they somehow get a gift from God and the translations begin to happen. As I said earlier, the story has problems with the end. The end meaning that after Ghazali,